Hi, my name's Oliver Rue, and I am a software engineer at Bloomberg in New York City. I'm the last Bloomberg presenter you'll see at this conference, unless someone put in for a lightning talk, then I'm sorry. But I'm here today to talk to you about a tool that my team built and some of the design that went into it. So at Bloomberg, I'm on a team that builds automation and tooling to make our infrastructure more reliable, scalable, and efficient. Now, without getting into too many details, a while back, we were tasked with building a new tool. Its purpose was to unify the existing tools used by our operations teams, and in doing so, increase their repeatability and efficiency. Now, for this tool, we knew we wanted an API to host it, but we also needed a CLI for individuals to interact with it. To achieve this, there's a fairly common pattern you might be familiar with. On one side, you have a REST API. It's got various methods and paths. It speaks JSON, and it's designed to be interacted with programmatically. And on the right, you have a CLI, made for human interactions, and it translates between the REST API operations and human-friendly command, syntax, and output. Usually, these applications are tightly coupled, and the CLI is purpose-written specifically for the latest API spec. However, from past experiences, we knew this design presented a couple challenges. We knew our API would have quite a few operations and might indeed never stop growing depending on the requirements of our infrastructure. While building a tightly coupled API and CLI might seem easier at first, keeping the two in sync can be cumbersome as the project grows. So let's talk a little bit about why. So a tightly coupled API and CLI is a simple and straightforward approach. The API is for programmatic access, the CLI is for human interaction, and the CLI code translates between the two. But when an API and CLI are tightly coupled, every time you modify one, you likely have to modify the other. You need to continually maintain two separate code bases with automation, deployments, and team knowledge, and you often need to deploy API and CLI versions together so that they can stay in sync and you don't have compatibility issues. It was at this point that we had an idea. We're already planning on maintaining good API docs for other API clients. So what if the CLI commands were just based on the API documentation? With this model, the CLI would generate its commands by simply reading the docs every time it starts. So when your CLI is auto-generated, new features and fixes only require an API change. And because of this, the API and CLI can never get out of sync. One major drawback is that it's a bit more complex than the simple model we discussed. And it should be noted that with this design, you still need to maintain two separate code bases and need to deploy the API and CLI separately. But the advantage comes from how this scales over time. In the beginning, the CLI and API will likely both be getting changed very frequently because they're under active development. But when the CLI matures and the API gets continual updates, such as bug fixes, new features, etc., the CLI should hopefully only require minimal maintenance. Effectively, at a certain point, you can stop deploying the CLI, but continue changing the API, and the CLI gets updated for free. So we assembled our first draft with simple one-to-one mappings between the API and CLI. API paths would map to space-separated CLI commands. Each path parameter, query parameter, and request body field would be a single CLI flag, and the CLI would just print the JSON API response. We weren't the first people to think of something like this. It's been done a couple times in the past. You can Google it or ask your favorite LLM to do it for you. But let's look at this scheme in a little more detail. So here's a sample API endpoint that's used to get a list of servers. It uses a get method. Its path is /device/compute/servers. It takes an optional cluster_name query parameter to filter results by cluster, and it responds with a JSON blob containing a list of found servers. Now, if we were to naively generate a CLI command from this endpoint, it would look something like this. To use it, you need to fully type out get device compute servers, specify your cluster with the --cluster_name flag, and you get back a HTTP status code and a huge JSON blob. If you can't already tell, this scheme leads to a bad CLI and is not much better than just using curl. So we realized that simply bolting the API and CLI together with some simple mappings was not going to work. Doing that created a really poor user experience in the CLI. The problem is that good APIs and CLIs are designed for very different purposes. APIs are made for programmers writing computer code, but CLIs are fundamentally a human interface. The underlying issue is that we were trying to map API concepts to the CLI domain, but REST API paths were never meant to be typed CLI commands. API parameter names were never meant to be typed CLI flags, and API response data is usually not meant to be consumed raw by humans. As we developed our first draft and ran into these issues, we kept trying to think of different ways to modify the API so that its directly mapped CLI commands would be more human-friendly. We could shorten our API paths so that the CLI commands are easier to type. Or maybe API path parameters could always become positional arguments in the CLI and not require flags. We had a couple more ideas like this, but ultimately we were looking at it in the wrong way. The end result would have been a bad API, a bad CLI, or both. If our CLI was going to auto-generate its commands from the API, we needed a translation layer in between. Then it occurred to us, maybe we can include this translation layer in our OpenAPI docs. The docs already contain all the basic information a client needs to know to use the API, so why not include a little additional information about how to define the CLI interface as well? You're clapping, that's good, I like it. One problem we saw was that typing out a long API path as a CLI command is a lot of work for a human and a very poor CLI user experience. Ideally, long API paths could be abstracted into succinct, intuitive CLI commands. So why not have the docs just define a CLI command for a given API endpoint? Then you go from this to this. Shorter commands mean less typing, but they're also cleaner and easier to understand. Another obvious problem we saw was API output formatting. REST APIs often speak JSON or some other structured data format, but they're usually not meant to be read by humans. Even if we pretty printed this JSON, it's still not going to be easy for a human to read. But what if the docs included instructions on how to translate the JSON into something easier to read? Then you can go from this to this. To accomplish this translation, but still keep the CLI completely decoupled from the API, we use Jinja templates. To accomplish this, if you're not familiar with Jinja, it's a relatively simple templating language with widespread use across the Python community. So the docs contain a server-defined Jinja template for each API endpoint, and the CLI simply passes the API response through the template to get the human-friendly output. Now, there's a bit more nuance to the output formatting problem. We also observed that CLI users often wanted the ability to display the same essential data, but in slightly different ways. For example, what if the user wanted this same output but as a CSV file instead of the table shown? It would be kind of silly to have multiple virtually identical API endpoints whose only difference was how the data was displayed to the CLI user. But we could have multiple Jinja templates per API endpoint and just give the user a way to choose between them. We could have one template to display the output as CSV, triggered by the --CSV flag. Maybe another template just to show network information, triggered by the --net flag. And of course, all these options would be shown to the users in the command help text. We also added a --JSON flag to every command. That's to give the user the option to get the raw API output and pipe it to a file or JQ or something else. Another issue we noticed involved how arguments were passed to the API. Originally, we just planned on adding one CLI flag per API argument. But take a look at this getServer command, which was generated from the API endpoint code shown above it. The --hostname flag really isn't buying us much. This API endpoint takes a single required argument, so it's just more for the user to type. Why not include the ability to make arguments positional, like this? A simple change, but it makes the command a lot more human-friendly. Staying on the topic of arguments, we noticed another unfortunate consequence of mapping API arguments directly to the CLI. It's often handy and good code hygiene to have descriptive variable names in your code. Here on the right, we have an example API endpoint that collects logs for a given server and saves them to a location on a file system. To represent the log file destination, we have a descriptive variable called destination_filepath. While this variable name might be helpful to programmers, it's an awfully long and cumbersome CLI flag to type, not to mention that the use of underscores and flags doesn't really follow POSIX conventions. So why not have the ability to specifically define the CLI flag and short flag used to represent a given API parameter? Like this. Now to specify the destination file path, you can use --dest path or just -p. Again, it's little improvements like this that go a long way in improving the CLI user's experience. The final problem we observed with API and CLI argument mapping was that sometimes arguments just couldn't be represented easily using simple strings. For example, what if the CLI command needed to upload a local file? What about Boolean CLI flags whose simple presence represents true? What about list arguments with a fixed or dynamic number of entries? We knew we needed to build a dynamic system to represent unusual API arguments on the CLI in a human-friendly way. So now that we have a good understanding of the problem, let's talk about how to implement it. We use many of the great open source projects that you see here, but we're primarily going to focus on FastAPI. If you aren't familiar with FastAPI, it's a great open source web framework for Python. While there are numerous good reasons to use FastAPI, one feature that we really love is the built-in support for OpenAPI doc generation. Here on the left, we have a simple FastAPI endpoint implementation with 2 endpoints. With just this code, FastAPI automatically generates the OpenAPI docs on the right. However, what we see on the right is not really the documentation itself. What you're seeing is just a pretty rendering of the actual documentation, which is defined in JSON and looks something like this. This JSON is the actual OpenAPI spec, and it contains all the information a client needs to know to call the API. And as you can see, the JSON contains a section for each path in the API. This is what our CLI will be parsing to generate its commands. Let's take a slightly closer look at how the OpenAPI JSON defines an API endpoint. Here on the right, you can see the OpenAPI JSON generated for the getHello endpoint shown on the left. It contains a summary, a description of parameters, along with a little bit more information that I left out for simplicity. For our use case, we need to define extra information for each API endpoint so the CLI can configure itself. So we just added a section like this. Each endpoint gets a CLI section that can define things like the actual CLI command, the Jinja formatters, and more. Fortunately for us, FastAPI has a neat keyword arg called OpenAPI Extra, and that allows the user to embed arbitrary information in the OpenAPI spec for an individual endpoint, and it's used like this. You just include your arbitrary object in the endpoint decorator, and it's automatically nested in the OpenAPI spec. We could just shoehorn a huge dictionary into every endpoint decorator, but that would be awfully crude and not very readable. So instead, we decided to implement our own child class of the FastAPI API router, but added a couple additional arguments to include the CLI specification, something like what's shown here. With that, now we can define our API endpoints and associated CLI commands like this. We write our endpoints just like we normally would with FastAPI, but with the option of specifying a CLI command in just a few extra lines. Of course, you still need to define the specific Jinja templates to pre-print the CLI output, but in many cases, we found that different endpoints could use identical templates, and there are tons of opportunities for code reuse. While this is all we need to describe the CLI command for an endpoint, we still haven't covered how to handle CLI arguments. FastAPI already offers a rich set of tools to define API argument behavior. Here's the query class. Here we use the query class to define API query parameters, and the field class to define individual fields in a JSON request body with Pydantic. There are similar classes to define other types of API arguments as well. The information defining these classes is also reflected in the generated OpenAPI JSON, and like the FastAPI endpoint decorators, it's also easy to just tack on extra information. So just like the endpoint CLI specification, we use Pydantic to define our model, add it to the argument declaration, and it automatically shows up in the OpenAPI JSON where it can be consumed by the CLI. So now that we have all the pieces to implement a CLI command for an API endpoint, let's put it all together. Here on the left, we have our endpoint from earlier that's used to get a list of servers. On the right, we have the CLI command that we want for this endpoint. To implement this CLI command, all you have to add is this. Just include a small amount of information about the CLI command, and FastAPI, API, and our dynamic FastAPI, OpenAPI, and our dynamic CLI take care of the rest. Hopefully by now you have a good understanding of the implementation, but I think a live demo is a really good way to showcase the utility of it. I've given this demo twice and it's gone really well. So maybe third time's a charm. We'll see, but just give me a moment to get it set up. All right. In this window here, we're going to run something called Infra API. It's a toy API made to interact with infrastructure. But it's not really doing anything. It's just running locally on my computer. All you really have to know about it is that it's written in FastAPI, and it includes the extra information we just talked about to define a CLI for it. And in this window, we're going to run something called Infra CLI. Can everyone read that? Just want to check, thanks. Infra CLI is a toy CLI to interact with infrastructure. But what it really is just a front on Infra API that I just showed you. All these commands here, get server, delete server, new server, those are all based off of API endpoints in Infra API. Every time Infra CLI starts, it calls out to Infra API, gets the OpenAPI JSON, parses it, and creates these commands. So let's take a look at one of these. So we've got Infra CLI list servers. It displays a list of known servers in the system. It's got a single -- cluster flag to optionally filter servers by cluster. And it's got 3 formatters, --JSON, --CSV, and one to just show network information. So let's see what it does. You run it, and it prints this nice column-separated table of servers. I can run list servers --CSV, same information in CSV. Now, we get some feedback from our users. They say, first of all, list servers is too much to type. We want it to be just LS servers. All right, fine. They say, you've got some pretty glaring typos in this help text here. You should probably fix those. And lastly, they say, you know, this CSV flag's great, but what would really be nice is a TSV flag, or tab separated value flag. Cool. Let's see what it takes to make those few changes. I'm going to do a tiny bit of live coding here. It's not important you read everything. The main point to take away is how little coding it takes to make those changes. So here on line 72, if you're at all familiar with FastAPI, you can see where we decorate our endpoint to make we decorate our function to make our API endpoint. Here's our API path /device/compute/servers. And then on line 76 here, we've got our CLI specification. That's where we define the CLI command for this API endpoint. So we've got our typo written help text here. We've got our command and our formatters. So let's fix them. We fix the help text. We change the command. And last thing we got to do is add another formatter. Those are in another file. They're defined like this, but we've got a CSV formatter that's a lot like TSV, so let's just copy it. We're going to replace all of our commas with tabs. Let's rename it dash TSV. Maybe add a short flag, dash T. And then our help text should say display servers in TSV format. All right, go back here. Last thing we have to do is import it. All right. Start it up, and it works. So that should have gone well. So if we go back to Infra CLI now, we see that list servers is now LS servers. And if we go in the LS servers help text, we'll see the description typos are fixed, and it's got a dash dash TSV flag. And if we use it, we see it's now tab separated values. That to recap, we just changed 3 different parts of CLI behavior without changing the CLI code at all. The only thing that changed was the API code. I want to show you one more thing. In this window, I'm going to run something called meal API. It's a mock API to interact with meal ideas. Written in FastAPI, just like Infra API, it includes the information to define a CLI for it. And in this window, we'll run meal CLI. CLI and interact with meal ideas. Meal CLI, meals. It'll show you some meals. Great. That's all I really want to show you about that, except that meal CLI and Infra CLI are the exact same thing. They're both something called auto CLI pointed at a different API. So if I want to run meal CLI, I just point auto CLI at localhost 8002. And if I want to run Infra CLI, you point it at 8001. That's an infinite number of virtual CLIs for one logical CLI codebase. And when you want to change the CLI behavior, you update the API, and the CLI gets updated for free. That is all I got. Thank you.
Nice. I got a number of questions for you here. I just have to roll myself up onto the stage after lunch. All right. I'm going to start from the top here. Although you mentioned command line interfaces are for humans, do you ever use command line interfaces for automation via shell scripts, etc.?
Yes, all the time. That's what a lot of our automation is. This tool wasn't really made for that. Our hope was that like programmatic users would hit the API, but yeah, we do that all the time.
I could totally see its use for things like this too. So yeah, I would same answer. What benefit does Jinja provide in this particular scenario? Why can't we use the same logic we define inside of the template directly and generate a string? I'm
not sure I understand the question.
Okay.
I mean, Jinja is used to translate what's essentially a dictionary into anything you want. And we thought of other ways to do that with while still embedding it in the API docs, but it seemed like the best option.
Okay, that's a fair answer. How do you measure the user experience for internal products such as this one? So how do you know that users like the changes or things like that?
We have a bunch of metrics and logging that are attached to this. Without going into too many details, we can see what commands users type and which ones they type incorrectly. But honestly, we more get feedback from having meetings with them. Like the tools we're making are made for operations teams that we work very closely with. So we try to set up meetings and say, what do you want? What sucks? What's good? And they give us feedback on that and we change it. And The model inherently makes it easy to do that because we add a little bit to the API and it automatically goes to the CLI. We're really to a point now where we can increase velocity of like deploying new commands to the CLI because it's so simple. It's one PR to the API code base and it just automatically goes out there.
Nice. Is AutoCLI.py open source?
I expected this to be the first question because it's a question I get every time I give this talk. No. But maybe. So I've gotten the okay tentatively to open source this in my company. It's just a matter of time. How it's implemented internally is not what I showed you. I kind of wrote what I showed you like completely separate from what we did internally just for the purposes of this talk. To do it right and open source it under my company, I got to put some time into it. But hopefully coming soon.
Nice.